afternoon, everyone. I'm a little bit curious, first of all, if you can hear me all right because of the noise. Am I yelling? Okay. Okay, so everybody can hear me. All right, good. Good afternoon and welcome to the Discoveries 2012 Connections Competition. My name is Roxy Hamilton, and I'm a talent program manager at OCE. This is the first year that I've been part of the Connections competition, so I'm as excited about it as you are. Each year, OCE is proud to present its top undergrad students in Ontario that have gone through the Connections program. These students that are here today have gone through a rigorous review process that has lasted weeks. And so we have what we believe to be the top undergraduate students here for you today. In any given year, OCE sponsors about 3,500 students through its programs. And this year, half of those 3,500 students were actually Connection students. So the competition was fairly fierce. This year, there were over 240 sponsored projects. That means we had many industry partners. And they happened at 20 different academic institutions across the province. So we're delighted to have this competition here today. I want to tell you before we go on about how the competition is going to go. We have divided the groups into 3 different categories. We have 15 presentations that will happen this afternoon. We have 5 college presentations, 5 university presentations, and then 5 Ontario Power Authority presentations. The last group is specially funded by the Ontario Power Authority, and those projects will focus on energy conservation. Our judges will be scoring the presentations using 5 criteria. They are the quality of each presentation, evaluating scientific and technical content, as well as speaker clarity, good visuals, and how the teams tackled the problem proposed by their industry partner. The scores will be tallied after the competition and the winners announced at the big lunch tomorrow afternoon. Now, before we go any further, before we start the presentations, I'd like to introduce our judges. Today, our first judge is Lucy Keating. Some of you may know Lucy from our value-added personnel program. She's been a course provider in that program for many years. And Lucy has designed and delivered many education programs for organizations across North America. With extensive project management experience and a particular strength in coordinating multidisciplinary teams, she works with a variety of engineering and technical groups to design communications focused on fostering understanding and acceptance of change. Thank you very much for being with us again, Lucy. Our next judge is Brian Armstrong. Brian is Executive Vice President and General Counsel for Bruce Power, Canada's only private sector nuclear generator. Since joining the company in 2000 as its senior legal officer, he has been responsible for building and managing the Bruce Power Law Division and for the company's corporate secretarial function. Welcome, Brian. Next on the judging panel is Corporate Director Bill McLean. Bill recently retired from IBM Canada after many years in a broad range of senior executive roles. In particular, his in-depth knowledge of operations and global strategy with respect to manufacturing and software development enabled a unique, competitive perspective internally and externally within the IT industry. On behalf of the IBM company, he was involved in many acquisitions across the product spectrum and was a member of IBM's Corporate Manufacturing Council. Thank you very much for being here today, Bill. Next is Jenny Mullinen. Jenny is the manager of the Technology Development and Conservation Funds at the Ontario Power Authority. The OPA is leading Ontario in the development of North America's most reliable, cost-effective, and sustainable electricity system. As manager of funds, Jenny is responsible for developing a portfolio of projects designed to test the next generation of supply and demand side technologies, conservation programs, approaches, and policies. The objective of these projects is to transform the market towards a culture of conservation and help Ontario reach its aggressive electricity targets. Thank you very much for coming, Jenny. And last but not least, we have Dr. Molly Choquette. Molly is Canada Research Chair in Tissue Engineering and Professor of Chemical Engineering and Applied Chemistry, and Biomaterials and Biomedical Engineering, University of Toronto. Molly is an expert in the study of polymers for drug delivery and regeneration, which are materials that promote healing in the body, and has published close to 400 papers, patents, and abstracts, and has given over 250 lectures worldwide. Thank you very much for joining us today, Molly. Okay, now we're ready to go. As you can see, or as you can hear, there's a lot of noise in the background, but I'm hoping that it's not going to disrupt our judges' evaluations or our presenters. So we'll get on with the show. I'd like to introduce our first team, which is going to be Elevator Cab Renovations, Environmental Chamber. Now this is, the next 5 presentations will be in the college category. And presenting we have Eric Hill-Keast, Morgan Corbett, Hamid Hameni, David Eckel, who is your presenter, Edward McEwen. Gentlemen, over to you.
Good afternoon, ladies and gentlemen. My name is David Eckel, and I will be speaking to you on behalf of the ECR Algonquin College Environmental Test Chamber Project Group. Let me introduce to you the team. On the electrical side, we have Ted McEwen on software and design, Morgan Corbett and Hamid Hamani on physical infrastructure, and on the mechanical side, we have Eric Hill-Keast, the team leader, and myself, concepts and construction. Our industrial partner, Elevator Cab Renovations, wants to take a dominant position in the $400 million elevator interiors market in North America. In order to achieve this, they must have a presence in every major city in North America. But elevator interior panels distort when atmospheric conditions change, and this happens both during transportation and after installation of the panels themselves. Currently, about 5% of ECR's expenses are losses due to environmental damage. So ECR must precondition each layer of its panel assemblies to center their atmospheric performance envelopes on the target region's conditions. So developing a standard table of performance is essential for efficient manufacturing without constantly engineering the panels. If this information can solve ECR's environmental damage problems, it will save their company over $200,000 annually. So ECR required a walk-in environmental chamber to do in-house testing and collect their own data for this standard table. This size of commercially available environmental chamber costs approximately $100,000. As a fully leveraged and high-growth company, ECR cannot afford the required chamber at that price. Our goal was to provide ECR with the chamber that they needed, but on a budget of $5,000. In a MacGyver-esque fashion, we accomplished our goal of creating a cost-effective alternative that meets ECR's requirements, but for 1/20th the cost of a commercially available unit. We did this by using readily available components, creatively and unconventionally. For example, the chamber itself is built around an existing elevator cab shell that we repurposed for our own use. We used a standard residential steam humidifier to provide the humidity for the chamber. And as well, we also adapted the system of a deep freeze refrigeration unit in an unconventional manner that would suit our specific application. Some of these concepts were abstract and required consultations with specialized technical experts as well. We would like to thank the Ontario Centres of Excellence for making it financially possible for us to contribute to industry in this meaningful way. Your Connections program is very well targeted. We would like to thank Algonquin College for the dedicated academic guidance of our professors and coordinators. We would like to thank Elevator Cab Renovations for giving us a real-world business and technical problem to solve, and for taking the time to guide us through the steps to completion. Finally, we would like to thank all of our various technical consultants and contributors for their mentorship and their efforts. I am pleased to announce that as a result of the success of our project, our team plans to form a company to pursue development and marketing of our project to a larger industrial audience. Thank you for your time and for listening, and I'd like to open up the floor to questions.
So maybe I'll start the questions. It wasn't clear whether you solved the problem. So we understand that there is a problem and you used your Geiger-esque methodologies to solve it, but it wasn't clear that you actually did solve it.
Okay. So essentially the chamber itself is used to provide ECR with the information that they will then use to solve their problem of environmental losses, like environmental damage losses. So the chamber itself has been built. We actually have it on display here at the conference. It just hasn't seen any testing yet, so ECR will use that to test their products, and with that information they'll then go on to improve their manufacturing processes so that they reduce their losses.
Just a quick question on the cost. The $5,000 that you talked about, I assume you met the target of $5,000 somehow in this work that you did. Is that right?
Yes. The $5,000 was our working budget between OC contributions and our industrial partner. Yeah. And just by creatively using the resources that we had and off-the-shelf parts and such, we were able to keep the price of that down to fulfill the needs of ECR with the $5,000 budget for making the chamber itself.
So what was the cost of making the chamber? That was really my question.
Yes. So it was our $5,000 budget. It was put into the parts needed to actually create the chamber. So, thank you.
Our next team from colleges is multi-purpose desktop prototyping system. And presenting we have Ricardo De Rosa.
Stand up here.
Good afternoon, ladies and gentlemen. My name is Ricardo De Rosa, and on behalf of George Brown College and my team, I'd like to present to you our project on multi-purpose desktop prototyping. With the help and support of our corporate partner, Ross & Dole Industrial Design, an engineering company that does a lot of consulting and brings a lot of new products to life, my team and I set forth to solve Ross & Dole's very common problem in the industry today. This problem is the prototyping process. The problem is that making prototypes is a very expensive, time-consuming endeavor that requires a high-skilled technician to operate sophisticated machine tools that can only be housed in large facilities. All these problems, as you see, require a lot of financial resources, and this is one of the main reasons why a lot of good ideas die on the design table because of the funding issues. Our prototyping machine will solve all the issues by making an open source desktop platform that will be affordable, easy to use, and accessible to all. At this time, I'd like to introduce my group members: Armin, Programming and Electronics; Milovan, Budgeting; Samson, Ergonomics and Design; and myself, Ricardo, the Project Manager and Head of Manufacturing. And wanted to say that working as a group was a really good experience, and we were very motivated to tackle any problems that we were about to foresee. One of those main problems that we encountered was actually the time it took to resource and research all of the custom components that we needed to order for the project. The solution around this problem is that we used an agile project management approach by working on other tasks on the critical path of the project. For example, we built a proof of concept miniature-sized machine to work out any of the potential problems that we anticipated. As you can see here on the right, this is just a mock-up of what we've done, and this approach helped us with the deadline and to make a working project. The main lesson that we learned is that the procurement process should never be underestimated, because we all know that it affects the deadline and it affects whether the project's going to be done or not. We also gained a better understanding on the time it takes to research for custom components. We developed a really strong relationship with Ross and Dole. We kept in regular contact with them on a weekly basis, and they provided us they support us with a great deal of professional advice and gave us access to their facilities, so we had a good understanding of what their business was all about and the space constraints and their needs. The noteworthy outcomes is that Ross and Dole plan to use our machine for rapid prototyping, and we know it will reduce their cost dramatically. We plan to use, although there is no current plan to take this machine to market, we would entertain any investors that are willing to commercialize it. As our GBC booth, just down the hall over here, you could guys take a look at our machine, what it looks like, but here's just a quick video to show you what this machine is all about. What you saw here was a video of our machine. It's a 3-axis milling machine. It's computer numerical controlled CNC, and it fits on a standard size desktop. The machine cuts out any object desirable, all automatically. The machine replicates the functionality of a normal CNC machine, but reduces the cost and size and the function. Reduces the cost and the function. Thank you very much. Thank you very much for your time. And any questions? Yes, they do. They do a lot of prototyping. They're a consulting company that help bring a lot of new entrepreneurs. They help them bring new products to life. So in order to reduce their cost, they need to do prototypes. Like they have to do that stage, that process in the manufacturing part of the application. Excuse me? Sorry. Sorry, I can't.
What were the financial benefits that your work delivered to Ross and Dole?
The financial benefits? It's going to help him develop all the prototypes in an in-house type of system. So it's going to reduce his costs he won't have to go to a machinist he won't have to pay a machinist to develop a prototype. He won't have to use the hourly rate that the machine costs. He won't have to do any of those things. It's all going to be made in-house. And it's an easy-to-use machine with an easy open-source platform. And he could manufacture pretty much anything.
Just for an example,
Here.
he does He does a lot of mold making. So some of the tools that he needs to make his molds with, they cost somewhere around like $5,000 a piece that he would have to buy. When he came and looked at the machine that we've designed, he can actually that machine will satisfy and make him he can make the tool that he would need for his mold making. So just like a random tool, it's $5,000, just like a number kind of there. But on the long run, it's going to be a lot on time and money. We just didn't have enough time to look at the cost that he's going to save yet.
Is that it? Thank you.
Okay, thank you.
Thanks very much, Team Prototype. Okay, next presentation from colleges is Keep Right Refrigeration Detailed Process Analysis Project. And presenting, we have Nathan Sukmanowski. Sorry about that. Over to you.
Okay. Hi, my name is Nathan Sukmanowski, and I'm representing Mohawk College for our lean manufacturing class. Okay, our project took place at Keep Right Refrigeration. As the name implies, they build industrial and commercial refrigeration. They were trying to initiate some lean manufacturing techniques, and I think with their past history, they had gone through some acquisitions and mergers, and they found themselves lacking the support that a large organization would have. So what they got us to do was to come in, a class of mechanical engineering students, and we took a look at their overall process and did a current state map. And we also did some future state maps built on our findings. So I'll start with the current state map. It would be nicer if these screens were larger, but hopefully I can explain this. Our group took a look at the manufacturing engineering. So we were based at looking at the floor order from the release down to production, to assembly, and then to shipping. Our current state, as you can see, the blue represents information travel, the black is material flow, and the red line pathways we designated as problems. So when the material leaves the scheduling and goes down to the first stage of the manufacturing, which is their bottleneck, was we described, was a flexible manufacturing system. From there, the material goes through, and after it leaves all the main fabrication, before it gets to assembly, it was determined that for some reason the paperwork went back to the office. This we found very, very perplexing. We also found that there was a lot of verbal communication as far as tracking information and reporting discrepancies. So the first map that we did, we took a look at doing the current state map for improving the communications. So what they already have there were a couple systems. One is called an AS400, which is a business software package, and the other one's called a Kronos. And the Kronos is just a simple timekeeping system that they usually use primarily for employee systems. But the advantages of the Kronos is that it can actually track material. You can use this system that they already own and put it in at every step. As well as the AS400, they can track and monitor all their material and communicate clearly. The next future state we took at was looking at doing a rework cell. The current state, because they had nothing but flexible manufacturing systems, when they were missing a part, a custom-made part, and it wasn't in a stock location, they had to send the order back to the office to have it re-nested and then sent back to the floor again. This could take a day, this could take 2 days, as the design staff only worked during the day shift. So if a part was missing on the second shift and the truck was waiting for it, they wouldn't get that part until the next day. So what we suggested was some very simple CNC machinery that is commonplace. It's a little obsolete, but it's still very effective. So in the case when they are missing a part in assembly, all they do is they go through a work order on the floor and they get it sent to the shear where it cuts the sheet metal part. It gets sent to the turret where it's punched and it's back into production. And then it's finished forming and it goes to where it needs to go quickly. And lastly, we did a racking simulation, because what we also found in their current state was with their custom-made, built-to-order parts, they had no designated locations for them, no home. They had home for stock parts, but they did not have anywhere for the assembly to know that that's where these custom-made parts are. So a very simple fix was to do a Kaizen, to have a shop floor team build and organize some racking systems. Very low cost, very effective. They could also opt to integrate the AS400 more. They could opt to integrate the Kronos more and have a complete materials requisition system where it's controlled and monitored by a designated person. So what we did here is we've taken all our ideas and we implemented a complete future state map that hopefully would have benefits as far as accurate tracking and locating a material through the entire process, control material flow to create a pull system from the assembly to the press shop, unlike the push system that they have in place now, recording of process times through the AS400 and the Kronos to accurately do scheduling and quoting, improvement in cycle times, and relief capacities for the bottleneck with the addition of the Rework Cell. A couple comparisons we'll go through. Thank you for this opportunity. I'd like to thank Dr. Louis Ornazio and the staff at Mohawk College. I'd like to thank the management at KeepRight. I'd like to thank the OCA, and I'd also like to thank the panel for their time. Thank you. Any questions?
Has it worked?
Yeah, well, that's sort of the difficult part to say. Has it worked? I mean, they were amazed. I think a lot of the information they already had, and they just needed someone to come in and say, look, you can do this. The tools are here. Build on it. Our role as a team going in there and breaking it down and saying these are problems, isolate the problems, identify the problems, give them solutions. Whether they get through to implement that, that's something I can't honestly say. I know that Mohawk College had an industrial engineering class as well that is in there doing their capstone projects and wrapping them up right now. So I know that they've been yielding improvements. How much they've actually taken from maybe the mechanical engineering project that we've done, I'm not willing to say.
Okay.
Anything else?
It sounds like you've identified some very specific solutions for them. In terms of the learning that your team gained, I'm wondering if there's one specific lesson that you did learn that you would be able to apply to any other future employer or industrial context. What was the big lesson?
I think really to kick over stones. To go out and look and investigate. I mean, it's easy enough. Again, at KeepRight, they had some very, very elaborate machinery, and they didn't understand that. Just go look at the issue. Some simple machinery would have fixed that. So just look over. Sometimes it's good to look at from 20,000 feet away. I think. So yeah, just investigation. Right. Thanks.
Thank you, Mohawk College. Our next presenter for colleges is Optical Techniques, Solutions for Fretboard. And this presentation is by Taylor Page from Niagara College. Taylor?
How's everyone doing today? All right, we're from Niagara College, from Niagara Research. We did the Balut ETAR research project. To my right here are my classmates and research partners, Andrew Gabrielli, Mike Mitzel, Matt Watts, and I'm Taylor Page. All right, so to start with a little bit of background, the ETAR is a device that Balut, a startup from Waterloo, is creating that solves a problem that specifically interests them quite a bit, but would be really good for consumers as well. It's taking the traditional Persian sitar, which is just a four-stringed instrument, and creating a MIDI interface that's extremely portable and easy to use that you could use to emulate any type of instrument by plugging it into a computer or a synthesizer. The requirements that were communicated to us by Balut was their current prototype uses metal strings making electrical contact with a circuit board. The problem with that is if you have any type of intermittent movement, you lose that contact, so it creates a lot of electrical noise. What they want us to do is develop an optical solution that would have less noise and just be a more clear contact. And they already have a prototype that they're ready to release to the market, but what they're looking at is further improving the ETAR. So it's possibly incorporating these into, say, the second version of the Balut ETAR. And one of the biggest things we want to keep cost down. So both the neck and the strumming portion as separate components would have to be under $10 so that they could sell it for a price point of around $100 to $150, making it extremely affordable. So our team was split into Mike and myself on the neck and Andrew and Matt on the strumming. And we kept regular contact with Balut. We started off the whole year with them coming down from Waterloo, taking time out of their busy schedules to communicate exactly what they wanted and some of the technologies that they wanted us to explore. And it was absolutely invaluable to how the rest of the year went because we had some really great notes and concrete ideas of what they wanted. We went on to have regular Skype meetings with them. I followed their YouTube channel and their Facebook, making sure I kept updated, and it really helped decide what direction I wanted to go in as they continually developed their current electronic prototype. All right. So the results were, for our prototypes, was it's fully expandable up to the 4 strings of the ETAR. We had an electronic design that uses a resistive touch interface, which was really important to Balut. They decided that along with our optical interfaces, they wanted one more type of electronic interface that used resistive touch. Our largest problem with that was making sure that stayed below the $10 price point because those components would end up costing $100 alone, which is why our optical design, which uses LEDs, I found was much more appealing since it used an array of just 10-cent LEDs wired in reverse that would cause them to act as light detectors as opposed to light emitters. And not only that, my favorite part about that part of the project was that there's currently LEDs already on the Balut ETAR, so those LEDs could just potentially be easily rewired in reverse and used to prototype this concept or even use it in conjunction with the existing ETAR as a type of error correction. And then our optical pickup that we designed for detecting strum was just simple. Our prototype was recycled out of an old computer mouse. We ran a string through a photo interrupter from the encoder, which senses how fast you move your scroll wheel. And we used that to sense the vibration of the strings, and then we can check direction of strum by which of the 2 sensors in the photo detector was triggered first. Also, just to go backtrack a sec, our biggest challenge definitely was keeping the cost of the neck down. That's why we went to the inventive method of using the LEDs in reverse bias, and we just showed that using creative development, we can really keep that cost down. So I'd just like to take a sec to thank Balut. They were amazing industry partners. We kept in great contact with them and really worked towards a goal that I think will benefit the ETAR in the future. Also, Niagara Research, Alex McGlashan and Lindsay, they were instrumental in our success. And the Ontario Centers of Excellence, you judges for taking time out of your busy schedules, I'm sure, to make it out today and be a part of this program. It's been very enriching to our education at Niagara College. Any questions?
I just was wondering, I know a little bit about music. Is this a patentable kind of item that you guys have got, or what?
I'm sure it is. You mean as far as the ETAR goes, or our specific?
Your specific solution here. Yeah.
I don't think that there's anything on the market that specifically works in this way, especially with the optical pickup, picking up the vibration of the strings. There are other companies, and even the current ETAR that uses several different types of electrical methods. But as far as the actual optical design of picking up the strings, I don't know. As far as we could tell, it hadn't been done. Otherwise, we would have looked at that.
So you mentioned that your team was broken up into the neck and strum teams. Can you talk a little bit about how you stayed coordinated and what was really key to moving the project team forward together?
Absolutely. Well, When it started out, it was very like written in stone. Okay, these two are working on this, and these two are working on that. But as the year progressed, we ended up working together quite a bit on each part of the puzzle. We were able to together solve the strumming problem within the first couple weeks. I mean, we didn't even have any funding for that. We just took apart an old computer mouse and had that prototype done. And then once we had funding, we were able to continue further, pretty much the four of us all together on the neck portion. And that's part of why all four of us are presenting together today. All right. Any other questions? All right. Thank you very much.
Thank you, Team Niagara. Our final college presentation today is for Timekeeper Pro, a project with Corbite Consulting Group, and presenting we have Terence Morrison. Would you like to come up?
Hello, my name is Terence Morrison. I'm here on the behalf of the Timekeeper Pro project from Algonquin College, and the other students that helped me in this project, that were affiliated in this project, were Vincent Macucci, Travis Luisais, and unfortunately Fabian Reclay was not able to be here today. Our project was to design and build a hockey scoreboard. You guys are probably wondering, well, what's so special about your scoreboard? What differentiates our scoreboard from others in the industry is how it's controlled. Most scoreboards in the industry right now are controlled by little controllers like this one here. Oftentimes they come with little to no instructions. Many of them don't even have screens. They're operated by like buttons and toggle switches. They're confusing. They're not very fun to operate. Our scoreboard, on the other hand, is controlled by the Timekeeper Pro software. It's a very intuitive, accurate, intelligent, and user-friendly program. Jeff Cordes, our industry partner, approached us at Algonquin College last September and said, look guys, I've designed the software, but I'd love to have it to actually control the scoreboard, but I have no background in electronics. Please help, I need help. So you see here how Jeff Cordes was responsible for everything that had to do with the computer. So obviously his software and the information that was being sent out. And we were responsible for capturing that information and then using it to control the scoreboard, which we also designed and built ourselves. The first few meetings we had with our industry partner were to discuss the problem definition of this project. A few of the scoreboard requirements that we came up with were obviously the scoreboard had to be controlled by the Timekeeper Pro software. It also had to be powered by a standard 120 volt outlet. It needed to be controlled by up to 200 feet away. The lights of the scoreboard need to be viewable from various angles and distances. It had to have a horn, and it needed to be completed under our $5,000 budget. OCE were generous enough to fund us with $3,500. Jeff Cordes also contributed $1,500 to our budget. Here you have a little price breakdown of our major expenses, and you can see at our total that we completed the project just under our allocated budget. Here's a Gantt chart of the timeline of our project. Gantt charts are an amazing time management tool. When we started this project, we weren't using Gantt charts, we weren't making schedules, and to be honest, we didn't really get a whole lot done. This was a problem, and to solve this, we started making schedules, we started setting goals, we were making Gantt charts to keep track of our progress, and the productivity of our group and our project increased immensely. As you see in blue there, most of our time was allocated to research. This was because not only do we have to learn a whole bunch of new principles in order to get this project done, but we also had a lot of discussions and debates with our industry partner, such as, do we buy certain parts or do we make them ourselves? Although you can't see Jeff in this picture, he's actually the one taking the picture. Our group booked conference rooms every week for weekly status meetings to keep our industry partner up to date, to let him know what the progress of the project was. And also, it was a great opportunity for him to ask us any questions about the project. And if for whatever reason we needed to get in contact with our industry partner, between those meetings, we all had each other's phone numbers and email addresses, and basically we stayed in constant contact. One thing that was really important that I learned in leading this project was the importance of learning the strengths and weaknesses of your teammates. Here you see Vincent, he's putting together the big scoreboard, the enclosure. Travis is going through the programming algorithms with one of our professors. Fabian's working on his computer, and I'm playing away with one of the printed circuit boards I designed. All this teamwork really paid off because we ended up making a small briefcase-sized scoreboard that could bring around to trade shows easily, as well as a big full-size scoreboard. Our industry partner was thrilled with the work that we achieved this year. So much so that he already has a few trade shows lined up. And he's also planning to talk to other scoreboard manufacturers to see, to pitch our ideas around. He even gave us the opportunity to become part of the Timekeeper Pro team and basically perfect this working prototype. I would like to take this opportunity to thank all of you who are here to listen to our presentation, and also to thank OCE and Algonquin College and Applied Research and Innovation, and of course Jeff Cordes, who helped us so much along the way. Thank you.
Maybe I can ask the first question. So this looks like it was a fantastic project, and you came up with a solution. Do you have any idea if it's better than what exists already?
Of course. It's like I said, it's almost as if the scoreboard industry has been sleeping for the last 15 years. You see the controllers that they're using right now, you have to have a really good working knowledge of the hockey game for the referee to come over and say, do this, 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 and to be able to do it really well. And if you haven't had experience with that particular controller, it's very easy to make mistakes, and it's hard to correct them on those controllers. And let's face it, when you have a whole bunch of people in the crowd yelling at you, and it's not a very fun experience. So our Timekeeper Pro software scoreboard is very easy to control, and hopefully will help revolutionize the whole industry of sports timekeeping. Currently, it is only applicable for hockey. However, because for this, for the prototype that we've made, it's more geared towards hockey. However, it wouldn't be. It's just a matter of somewhat tweaking the program for like. You could use it for any sport. It was just a matter of maybe altering the placement of the numbers on the scoreboard, modifying the program a little bit. But sorry. Oh yeah, of course. Yeah. That's another thing too, because right now most of the local arenas are getting their scoreboards imported from the States. So by having, hopefully by having a main distributor or manufacturer in Canada, it could boost Canada's economy as well. Thank you.
Thank you, Team Algonquin. That was the last college presentation, and before we go any further, I've just been advised that the business mentoring that's happening at the very back here, and which is part of the Guinness World Book of Records competition that we've got going, is looking for more proteges. So if any of the college students who just presented are interested in being part of that Guinness Book competition, then please follow Andrea. Okay, she'll take you back there. So moving on to universities. Our first university, actually it's the OPA, it's Ontario Power Authority presentations we'll move to next. And the first one that we have here is Automated Snow Removal System, which is being presented by Walid Ishaq from the University of Toronto. And the industry partner is Gerard Merrick Marketing
can start. Can you guys hear me at the back? All right, perfect. More than 70% of all solar panels installed globally are in areas of snowfall. Hi, I'm Waleed, and with me here are my teammates, Yaroslav and Irshad. Our clients, Generic Marketing Systems and Gemini International, brought to us a very interesting problem of snow cover on solar panels. Snow cover causes two main problems. First, it prevents the persistent power required by many technical off-grid applications. Second, as the solar panel stops producing power, the batteries stop charging, and eventually, due to cold weather, their electrolyte solution freezes, expands, and cracks open the battery casing. Replacing a 2 kilowatt-hour battery will cost you $200, but most importantly, it will cause an environmental risk of acid leakage. To fix this problem, our client wanted to develop a fully mechanical and automatic system to remove snow from the solar panels. Currently on the market, snow is largely removed using manual methods such as roof rakes. However, in certain remote technical off-grid applications such as this weather station, it may not be viable to do so, and in some cases not possible at all. To solve this problem, our solution is the automated snow removal system. The ASRS is based on 4 design values: simplicity, sustainability, durability, and automation. We have designed a fully mechanical and automatic system that senses the snow accumulation on the solar panel, tilts it vertically, and removes the snow. With only 4 moving parts, we have maximized reliability without compromising any functionality. Of course, the ASRS looks simple on the outside. The underlying physics is much more complicated and can be represented by this graph. For instance, the point of intersection between the black and the blue curve represents the point at which enough snow has accumulated on the solar panel to tilt it vertically. Once that has happened, the distance between the black and the orange curve represents the amount of snow that has to come off for the solar panel to go back to its initial position. Our design approach relies heavily on iterative process. After building a basic mathematical model, we dove right into our first prototype. And using inexpensive materials, we built 3 prototypes, which were used to test and verify the functionality of our design. And of course, there were many challenges along the way, and one of the biggest challenges we faced was towards the parts acquisition phase of our final model. And instead of idling away time, we dynamically adjusted our project plan and used our resources to work on other tasks. As you can see, democratic management was a big player in our success. We took advantage of our small team size, as you can see, 3 members, to involve everybody in the design stages with equal say in all decisions. That led to a high productivity rate, which allowed us to finish our project on time and on budget. Our team operated on 3 key fundamentals of involving all stakeholders, listening to the needs of the client, and adding value. All our communications were open and transparent and involved all the stakeholders. We had weekly meetings with our clients to not only update our progress, but also to listen to their changing needs. And we added value by making sure we maximize the amount of experience we were adding to the product development experience for the client. What I mean by that is we didn't stop at building a model. We created a full market analysis, economic analysis, a product logo, and a market campaign for our clients, just in case if they really love it, they can go ahead and start selling the product. This concludes our presentation. I would like to thank, on my team's behalf, the OCE and the OPA and all our sponsors for their support. Thank you.
How does the mass of the snow influence your design?
Well, to answer that question, we designed the ASRS to be very easily customizable. So you can move the counterweight anywhere to adjust maybe for a 40-pound snow load, which is on a 200-watt solar panel, about an inch of snow. Maybe if you want to wait until it accumulates more snow, you simply move the counterweight back, and now it'll tip at 60 pounds of snow. So it's fully in our power to customize it, as you've seen from our graph, and in the power of the customer.
Is your industry partner taking on your solution, your recommendation?
Our clients actually plan to make a hybrid solution for a greenhouse with wind turbine and a solar panel system, and he plans to use this and the wind turbine system, which you will see, I believe, in the next presentation. I'm sorry? No, due to time constraints, we weren't able to, and of course the winter we had, it was hard to simulate snow. But in fact, in our report, we do recommend for the next students to, who will take over the project, to collaborate with Queen's University and join their open field testing for solar panels. Basically what they have is a fully open field with video feed and recording to monitor the behavior of the system. So in fact, we can install this on the field and observe the behavior under winter conditions, snow, rain, hail, and basically have raw data for verifying the functionality of our design and possibly improve if to learn something new about it, sure. Any more questions? We have 8 seconds. Right? Yeah. Thank you.
Thank you, University of Toronto. Next presenting is Queen's University, evaluation of new turbine generator technology, and presenting is Ron Yan.
Okay, so good afternoon, everyone. My name is Ron Yan, and I'm here with Katie Pelche today to present our project entitled Low Head Turbine Technologies for Ontario Power Generation. Yeah, so in order to maintain appropriate flow rates in rivers, hydroelectric dams often use a bypass structure, diverting water around their turbines. Occasionally, there are also other civil structures installed in a river designed simply to control the flow. When you have a situation where water is not flowing through a turbine, the energy in the water is lost. Now, traditional turbine technologies rely on a significant height difference between the headwaters and the tailwaters. Now, these conditions don't exist at these bypass sites. So our group was asked to investigate turbine technologies that could work at lower hydraulic heads as part of a larger 75 megawatt project on the Little Jackfish River located in Northern Ontario. We were asked to research environmentally friendly turbines that could capture some of this lost energy with minimal disturbances to the fish in the river. So at first, as a group of chemical engineering students, we were a bit overwhelmed. We thought, isn't this something mechanical or electrical engineering students should be working on? We were a bit baffled as to why we got this assignment, but we had a network of supporters to help us out. And with our support group, we were able to burst the chem-eng bubble. We met with our advisor, an electrical engineering consultant who works for Worley Parsons. We consulted with professors in the departments of mechanical and civil engineering at Queen's. And of course, we contacted numerous vendors of the various turbine technologies that we were investigating. We found that the vendors, for the most part, were very helpful, even towards a group of students. But we quickly learned that they forget about your project unless you contact them frequently. We made bi-weekly conference calls with our client contact at OPG, and we made 3 visits to OPG's offices, including a site visit to OPG's generating station in Campbellford, which really gave our group a chance to visualize and understand the power generating process. What really pulled us through the project was our group dynamic. Each of our group members found our own strengths to contribute, and together we learned the importance of having a team where our strengths complemented each other, but yet we were still allowed to take on new challenges and gain new skills. So in the end, what suitable technologies did we find? We have the tried and the true Kaplan turbine. We found a dinosaur in the Archimedes screw, and a few new kids on the block, the VLH turbine, or very low head, and the Alden turbine, a variation of the Kaplan turbine that's more fish-friendly. We also found the Gorlov helical turbine, which we managed to model and fabricate in a 3D rapid prototyper and test using equipment in the civil engineering department. And we brought along a model that we printed out using our prototyper. Now, our proposed solution of installing VLH turbines at the Summit Control Site and a Kaplan turbine at the main dam bypass was predicted to add 3.5 megawatts of power generation to the Little Jackfish project, enough power to supply an additional 1,800 homes with clean, renewable power. We delivered our final presentation to OPG about a month ago, and with very positive feedback from our client, as well as the other OPG employees that were in attendance. Although OPG is still a little over a year away from breaking ground on the Little Jackfish project, we've found it important to emphasize that these technologies are also applicable to other sites that are operated by OPG. And for example, they run 65 other hydroelectric facilities just in Ontario. So the project really allowed us to learn a great deal about the power generating industry in Ontario, and our group is eagerly awaiting to see if some of our recommendations make it into the final project. So at this time, Katie and I will be happy to answer any questions you might have. Thank you.
If you were to go back, is there one thing that you would do differently?
I think probably the biggest change we would have made is starting to contact vendors a lot sooner in our process than we ended up doing so. We began calling in mid-January, so we had researched and come up with a final list of technologies that had interested us, and then we started contacting vendors for quotes. At the end of the project, or towards the end of March, I guess it was, we only had 3 quotes, unfortunately. So just getting through their process, getting through their screening processes, providing them with enough information and getting enough feedback from them was a much longer process than we anticipated for the project.
As chemical engineers, why were you given this assignment? Did you ever find out?
We ranked our project preferences, and then our instructor had some type of algorithm that sorted us. But in the end, we really learned a lot from we learned the versatility of our chemical engineering degrees. We found we're just chemical engineers, that's just the name, but we can do some of these other things as well.
Very good, thank you.
Thank you, Queen's University. Next presenter is Christopher Adams for Algonquin College, and his project is electricity, or his team's project, sorry, is electricity usage and demand monitoring.
Thanks. Hi, my name's Christopher Adams. These are my colleagues Sean Warren and TJ Woodbeck, and we're the electricity usage and demand monitoring of Algonquin College project team. Each year, Algonquin College spends millions of dollars on the cost of electricity. With the college expanding and the student population increasing yearly, these costs are expected only to rise. Our team has worked with the Physical Resource Department at Algonquin College to analyze and report trends in electricity consumption. Doing so, we can improve the management and the understanding of electricity at the college, ultimately reducing electrical expenses. To effectively analyze electricity consumption at Algonquin, we've updated a database containing electrical data and related data to electricity usage, such as temperature and hourly Ontario energy pricing. Currently, our database contains this data at 5-minute intervals from September of 2007 to actually yesterday. To effectively analyze this large amount of data in our database, we've used the macro feature within Microsoft Excel to program analysis tools. These tools have allowed us to answer many of the questions our industrial partner had asked of us, and some of the capabilities of these tools allow us to indicate when electricity use is highest and lowest. They allow us to average the electricity consumption for each hour of the week, so we can determine when electricity use is highest and lowest.
Additionally, we've created a tool that will generate a monthly report containing all of the necessary data for calculating electrical expenses. Early on in our project, our team had created a Gantt chart to schedule project tasks to ensure our project was on track and we were able to complete it successfully. This led to us actually completing our tasks at least on time or ahead of schedule, which allowed us to create additional tools for our industrial partner. To stay organized, our team members met at least once a week. Additionally, we stayed in contact through the use of email and social media. One of the greatest challenges our team has encountered in the duration of our project was a period of time in September where we were missing a series of electrical data from our data source. To solve this problem, we used a secondary data source. The only problem being this data was available at 15-minute intervals instead of the preferred 5-minute intervals. To overcome this, our team created a tool to estimate the data between the 15-minute intervals so we're able to easily insert it into our database, leaving our database complete and allowing us to accurately analyze the electricity consumption at the college. Our team stayed in contact with our industrial partner through the use of email, and we scheduled meetings with him through the use of email as well. In the beginning, the focus of our meetings were determining project requirements and project expectations. Later on, we didn't meet quite as often with our industrial partner. However, when we did, the focus of our meetings were to report project trends and overall project progress. In the end, our industrial partner was extremely pleased with our project and the analysis tools that we've created, and he was actually going to use the analysis tools to further analyze the data in the future. Some of the outcomes that we've found, we are able to recommend strategies the college can use to reduce electrical costs. Additionally, like I mentioned earlier, our team handed over all of our analysis tools to our industrial partner so he could answer any questions he may have in the future. Our team gained valuable experience using Microsoft Excel and programming during this project, which is a pretty good skill to have in the workplace. And we'd just like to thank our industrial partner, the Ontario Power Authority, for their contribution, Alex Yang, our professor, and of course everyone here for watching our presentation. Thank you.
Just wondered, did you get any kind of a feel from your industrial partner as to what the financial benefits actually were?
Yeah, our industrial partner, like the college uses so much electricity, even saving, using these strategies to save a little bit would result in a lot of money being saved by the college. And he definitely was going to use our analysis tools to see where he could save some money for the college.
And were you able to identify some specific opportunities for them?
Yeah, we analyzed the hourly Ontario energy pricing. Just a bit of background about it. It changes for industries every hour of the week. So this hour today, the cost of electricity is different than next month. We've indicated times where electricity consumption costs are the highest, and we can target those times to reduce the electricity consumption because that's when it's going to be the most cost effective.
And were you able to identify specific opportunities for reducing?
We made some recommendations, such as we could run air conditioning a little bit harder during the lower periods of time, and just reduce it a little bit during the times where electricity was going to be a little more expensive. Most likely, people weren't going to notice a 1 or 2 degree change in the temperature. Any more? Thank you.
Thank you, Algonquin College. Okay, next we have from Queen's University, we have McLean Shea and his team, who is going to present on PowerStream EV battery to grid energy. Over to you.
Good afternoon, everyone. My name is McLean Shea. I'm here with Chris Harris, and our other teammates are John Sparks and Vaughn DeMarco. The media has been filled with stories of the emergence of electric vehicles, or EVs. Last year, President Obama announced his plans to have 1 million EVs on the road in America by 2015. And there are plans for many of these EVs to double as emergency power sources. But why not take it one step further? The vehicle-to-grid concept, or V2G, would allow EVs to act as battery backup for the entire power grid, supplying or drawing energy on demand. And that's exactly what our client was interested in. And I apologize quickly here, the formatting seems to have screwed up. I promised it looked better before. So our client was PowerStream, an electric utility just north of Toronto. They wanted to know how they could prepare for and take advantage of V2G. So at our first client site visit, we spent the afternoon meeting with engineers and program managers to understand their business. And we came away with 3 key topics that we felt would drive our project forwards. The first was the economics of power aggregation. The second was the key players and partnerships. And finally, the impact on grid infrastructure. Having established our approach, we created a Gantt chart, but we found that given the vast amounts of information we were dealing with, it was really our weekly memos and our progress reports and our briefing papers that allowed us to stay organized. Following our first design review, we had a major challenge, and that was just too much feedback. We had it not only from our client, but also from Better Place, an EV service provider, Nissan Canada, and Viridian Connections, another electric utility. We had to filter through all of the recommendations and strike a balance between our time constraints and adding the most value we could for the client. Now, at the core of our work were our weekly supervisor and twice-weekly team meetings, which used to bounce ideas off each other. So John, working on the economic model, might have needed feedback on the assumptions in a new financial algorithm. Or Chris, working on potential business strategies, might have run a game theory activity. Now, these weren't traditional engineering design tools, so we really had to push outside of our comfort zone. We found that our industry contacts could be of immense help. So Nissan Canada and Better Place both provided proprietary projections, and Viridian acted as a sounding board for potential partnership strategies. We also met with Navigant, an energy consultancy that gave us feedback as to the structure of our economic model. And of course, all along the way, PowerStream acted as a guide during our bi-weekly conference calls. And that brought us to our final design presentation and our results. So I want to briefly outline the different markets that are available for V2G power aggregation. The first is regulation services, in which EVs would be contracted to provide energy, relatively small amounts, to match system generation with demand. The second is operating reserves, in which EVs would again be on contract to provide energy in the event of an unexpected spike in demand. And finally, we have peak offset, in which EVs would provide or would draw in energy at night when it's inexpensive and feed it back to the grid during the day at periods of high demand. So what our team did was put together an economic model that would forecast the profitability of each of these markets. Now, and the results you can see are on the right. Regulation services is the top line in blue, and it's consistently the most profitable. By 2020, it has the potential to net PowerStream over $3 million in annual profit, not taking into account the amortized startup costs. Now, the biggest challenge we faced in this project was creating a deliverable that would continue to be useful over the next decade as V2G technology evolves. A static chart like this is good for a year, if you're lucky. So we developed an economic model that was dynamic, easy to update, and user-friendly. And we also conducted a sensitivity analysis on each of the hundreds of variables involved so that we could identify to PowerStream which were most important to watch. PowerStream's request was very much for a strategic assessment of the V2G market. So we developed the tools and evaluations necessary for them to make informed decisions. Our economic model will allow them to accurately track profit margins. Our evaluation of potential partnership strategies will allow them to choose appropriate business paths forward. Our analysis of the impact on residential transformers will allow their engineers to develop technical solutions. And our breakdown of the power grid and environmental implications demonstrates the wider benefits of V2G integration. PowerStream is really excited to share our work publicly. They're very generous, and with a little modification, this work could apply to any power utility in Ontario and potentially beyond. We'd like to thank everyone that was involved with the project, along with the OCE, OPA, and NSERC. Our professor has reminded us countless times that industry is multidisciplinary. You have to take on whatever's thrown at you, and I know that this project has helped us to prepare for that. Are there any questions?
Has PowerStream told you what they're going to do with your work?
Yeah, so they've our main client contact, Dave Burns, is responsible for now taking the model, working through it, coming to understand it fully, and they're going to be working with our program again next year and hopefully moving forwards with some implementation strategies. Our project really was a research project to allow them to frame their thinking on V2G, but we've definitely provided a number of steps forward for them to do that, and they seem very excited and showed their pleasure in what we were doing.
What are the key variables in the dynamic model that you've built?
So that's a very broad question. Each of those different markets has its own completely separate analysis, but the big factors are the cost aspects of the batteries. So the more it costs to make a battery, the more costs you have related to V2G, because the more energy you're putting through a battery, the more degradation there is, and the shorter its lifetime. So one of the biggest ones was the cost to produce batteries, but also the cost differential between, say, for peak offset, how cheap it is at night and how expensive it is during the day. So things like that.
Is anyone considering a career in the energy sector?
Yeah, so it's certainly something that's very interesting. The work we've done here obviously belongs to PowerStream, and they're excited to share it. But certainly working in consulting in the energy industry could be very interesting. Thank you.
Thank you, Queens. And our last university presentation is by Mohammed Ashraf Maslan, who's going from the University of Toronto, who's going to present on customizable wind turbine blades with an industry partner of Duran Merrick Marketing Systems.
Good afternoon, everyone. My name is Ashraf Maslan, and I'm here together with my team from University of Toronto, which consists of Mugilan Ilangovan and Fakri Ali. And our project is low TSR customizable wind turbine blade profile, which is in partnership with Joran Marketing System. So essentially what we're building is a program to help users build their own wind turbine right here, using PVC pipes in a low wind speed area. So the objectives of the program itself, which is shown there, is that it's going to take all this input, diameter, length, number of blades, and as well as tip speed ratio, and it's going to output a blade profile that is traceable on the pipe right here. So, and it should also be inexpensive and user-friendly. As for the turbine itself, it should spin at minimal noise, and it should also be inexpensive and easy to build. For the constraints, we have few constraints that is both set up by our client and by our group as well. The first of all, it has to run without the need to install any advanced software. Therefore, our group resulted to Microsoft Excel for this. Secondly, it has to be designed out of pipe sections, as I mentioned. Third, it must run at low wind speed, which we define to be 2.5 meters per second. And lastly, it must have high solidity to be visible for birds. And the result out of this project is that we got two different blade profiles. The first one is this one, which is TSL range of 1 to 2. It is based on NACA 2414 blade profile and is able to spin at low wind speed, as low as 1 meter per second. And the second one is TSR 2 to 3, which is based on trial and error method. It is our own creation, and it actually delivers more power and as it can rotate at higher RPM. And over the course of 1 year, we have built over 40 prototypes of this. And we tested all of them. And the data from this testing is the foundation of our program. As for communications, the communication between our industrial partner and ourselves mainly involve weekly meetings as well as emails. And not only transferal of intellectual happens, our client actually helped us to build a hub fixture for our prototype as well. So midway through this project, we actually had to change our industrial partner due to some unforeseen circumstances. So how we deal with that is we just accept the new industrial partner. We brief them about our current status, and we kept in touch with the previous clients with all of our proceedings. As communication between group members ourselves, the most thing to note is that we develop a specialization system so that the building process of the many wind turbines is quick and smooth. Everybody knows what they are doing before we step into a workshop, and that is useful for us to complete this project in time. We also appointed a team leader as well as a dedicated contact person. As for challenges, again, we have been building 40 prototypes of the wind turbine. So we needed a source of reliable and constant wind source. Therefore, how we deal with this is that we set up a temporary wind tunnel setup using narrow hallways of building in U of T. So what we do is we also got a bigger fan which is capable of delivering up to 4 meters per second. And since the narrow hallways managed to contain all the wind, it actually created a good venturi effect that we could use to as a reliable source of wind. And as I mentioned earlier, initially we built our program using MATLAB. However, our client didn't want us to pursue with MATLAB because MATLAB codes are hard to read and future development is deemed impossible. So therefore, we resorted to Microsoft Excel. And what we got out of it is a light program, which is only 2 megabytes in size. It is easily downloadable and it is executable on most computers, Mac, Linux, you name it. So for applications, we envision our program to be used as urban wind turbine. Imagine every house have one of these because it is so cheap and easy to build. And since we have rotational mechanical energy from low wind speed, from 1 meter per second, it can also be used to grind mills and pump waters. I envision this to be deployed in developing nations where efficient wind turbine can be built out of cheap materials and it could be used to help them pump water more efficiently. As for conclusion, we have built 2 independent blade profile sets, TSI 122 and 223. And the program is built on Microsoft Excel and is ready to be downloaded right now. And most important of all, at low wind speed, again, 1 meter per second to 2.5 meter per second, it performs better than a commercial wind turbine. Thank you. Questions?
Do you, hi over here, do you have any idea in terms of durability?
We actually have a working prototype and we put it outside and it will just spin and spin for hours in a day. So in a sense, it is very durable, even in winter conditions. Because it spins at a very low wind speed and the generator that we hook it up to is reliable. Yes.
But do you know how your polymer is going to change, like in sun or like in different environmental conditions?
In terms of this pipe, it is also being used outdoors currently as sewage pipe. So it is already been exposed in winter conditions, in cold and hot conditions. So it is proven to be able to last in those conditions. So therefore, I believe that this is going to last as well. Any? Thank you.
Thank you, University of Toronto. And that was our final presentation in the category of Ontario Power Authority presentations. We are going to move now over to the university section for 5 presentations, the first of which will be the team from McMaster University, and they are presenting on plasma cutting machine. Industry partner is Sector Technology Inc., and the presenter is Ben Desclouds.
Hi, my name is Ben Desclouds, and on behalf of my team, I'm here to present our sector technology project. We're representing McMaster University, and we're a team composed of materials engineering and mechanical engineering students. And what we did was we worked with Sector Technologies, whose mission is to create unique and custom cutting technology solutions to meet each individual client's needs. So what they do right now is they make large-scale plasma cutting machines around 480 feet squared. So what our company contact Bill Dell saw for us was that this industry was moving towards the smaller segment. It was moving towards what our project was based on, a 4x4 plasma cutting machine at the $10,000 price point with a 30% margin and a 10 machine payback. This machine had to be aligned with Sector's current manufacturing technologies and capabilities, and what it needed to, and it had to be a small machine that acted like a big machine. Like one of theirs, be built like one of their big machines, and act like it. So the first thing that we did was we went out and we talked to the customers, not just Sector. We went out and talked to the potential customers. We went and identified two segments that we wanted to target, schools and metal shops. Each had unique needs for the project, and this was incredibly valuable going forward with the design. The next step was to analyze the competition in the market. What was the indirect competition doing? Waterjet, oxy-fuel. What were they doing? How were they cutting? What were they doing for this smaller segment? Also, direct competition. Tracker and Torchmate were the two main competitors. What were they doing? And these findings, combined with the customer requirements, as well as Sector's requirements for the project, came to our 5 major challenges for the project. The first challenge being to maximize versatility. And the way that we did this was with our variable head. It's a completely unique design, unlike anything else in the market right now for this small segment. This is a prototype right here. We rapid prototyped it and laser cut it, but right now it's being completely built at Sector Technology for not just their small machines, but for their larger machines. And the reason that this increases versatility is that it can hold any type of hand torch that a company may have already. It can hold any type of machine torch that it already has. As well, it allows for different types of beveled cuts just in one type of variable head, maximizing the versatility and maximizing the value of the machine. Sorry. And then for the footprint reduction is our second major challenge. So traditionally what the competitors do is they have a gantry system, which is a column, a beam, and a column. So what we did was to minimize the footprint. We took off one of the columns. We proved through engineering calculations that our cantilever design would work. And by taking off one of the sides, we reduced the footprint, but also allowed for larger sheets to be cut, not just 4x4 sheets of metal. So it adds the versatility while minimizing the footprint to maximize the value of the space on the shop floor. The third challenge was, as engineers, we think about, what are the stresses? What are the forces on the machine? What materials are going to be used? But what Sector Technology showed us was different questions that we should be asking. How is it going to be assembled? How is it going to be disassembled? What happens if a part breaks? Is it easy to get to and replace? These are questions that the customer asked them. So these are things that we had to take into account as we move forward. Learning these different types of questions was incredibly valuable experience when going forward with our design. We took this into account and we delivered a product that not only aligned with the customer's needs, but also with Sector's manufacturing capabilities. The fourth thing is safety. When we're going and targeting schools, safety becomes even more a priority. So what we did was we put a standard water table on our machine, something that the competition does not do right now, and that catches harmful dust particles in right at the source of the plasma cutting. So the fifth challenge was to maximize the customer base. So we did this in multiple different ways by offering different types of control systems, but also having the machine torch capabilities as well as the hand torch capabilities. We ran all this through an expected commercial value model, and we showed that our product breaks even within the second year with a highly positive expected commercial value for the product. So we delivered to Sector designs and drawings complete with our engineering calculations, a full implementation strategy, as well as we've shown that the product is commercially feasible, technically viable, and it will work in the market. So not only will this differentiate their product line, but it also will promote the industry that they're in. So thank you very much. for your time, and we'd like to open the floor to any questions. Thank you.
I'd be interested in knowing what sector is going to do with this technology, because in this industry, a lot of stuff is patentable, really patentable, and are they doing anything with it in that regard at all?
So with regards to patents, I'm not sure what they plan on doing, but they are planning on building that. They have started building this, and they will start building our machine quite soon. They just have to work on the electrical part of the machine was out of the scope of our project, so that is something that they have to continue to develop, but we have no doubt in our minds that it will work based on our mechanical design. Any other questions? Nope. All right, thank you very much.
Oh, thank you. Thank you, McMaster. Moving on. Next is University of Ottawa. They will be presenting on enhanced induction generator for wind energy converters. And the presenter is Kyungjin Tang, and I hope I'm pronouncing that right. Is the team here? University of Ottawa and Trias? Well, we'll move ahead until we just find that team. We'll move to the next team, which is University of Western Ontario. And they'll be presenting on design of flaps for D-Jet. And presenter will be Adam Shea. Industry partner is Diamond Aircraft Industries, Inc. Have they left the building? Oh, okay, moving right along. We have some people who'll track them down. So we'll move on to the Ontario Institute of Technology. Are you here? Oh, good. Okay. And they'll be presenting use of a variable mechanism to alter the flow of a centrifugal coolant pump for use in the automotive industry. And presenting will be Justin Vandenbosch. The industry partner is Magna Powertrain Systems. Over to you.
Thank you very much. Can everyone hear me good? All right. So, good afternoon, ladies and gentlemen. My name is Justin Vandenbosch. I'm here today with my partners, Kevin Cuddy and Paul Craven. We're here with the University of Ontario Institute of Technology. And this last year, we have been working with Magna Powertrain to create a variable flow coolant pump for use in automotive industry. I'll explain what that is. So basically in automotive emissions standards, they look at an entire range of how a car works from initial startup to actual running time. A cold engine is actually a very inefficient engine, so there is currently a lot of drive in the industry to create an engine that warms up really quickly, that warms up faster from cold start when there's lots of viscous oil and lots of things in the engine that aren't up to temperature yet. So there is a thermostat to do this, however, they are currently looking for ways to do this within the pump itself. The solution for this would be to create a variable flow pump, which provides a full amount of flow or a reduced amount of flow in case of a cold start. So a traditional cooling system, as you can see, has a radiator, has a coolant pump, has hoses that pumps coolant throughout an automotive engine. Most cars have a thermostat equipped, which will bypass the coolant from going through the radiator. However, it's still pumping coolant through the engine and therefore cooling the engine when it does not need to be cooled. So looking at the pump itself, we have a centrifugal pump, which is the one most commonly used in the industry and is comprised of an impeller and a casing. And it's very simple. The impeller spins, the coolant hits it, flows outside the casing, and is pushed through the engine in that manner. When looking at this, there are several very, very key areas in which you change these pumps and it changes the characteristic of the pump, whether changing the walls, changing the blade impeller angle and everything of this sort changes how the pump works. While I was actually doing an internship for Magna Powertrain and learning about all this stuff, there was a requirement for variable flow coolant pumps, and started learning about all these things and actually found a couple ways which makes pumps inefficient. And I started thinking, hey, if we can make pumps inefficient but also make them more efficient variably, this is exactly what we are desired to do. There's been lots of other solutions which have been done externally outside of the pump in terms of clutches and everything like this, but these are greatly complex and introduce a whole cost segment into this, which is not usually involved in a water pump, which is only in the $10 to $15 range. So a few of the obstacles we overcame were initially we approached Magna and approached UIT with this problem. They gave us some direction, they gave some guidance, and then we had to figure out all the non-disclosure agreement and the intellectual property. This took forever, and we greatly underestimated how long this took, and yeah. So that was our big obstacle, and by the time we got all this sorted out, we actually ran out of time to book all the testing time we needed on the testing stands that we were using at Magna. So ended up broadening the project scope and actually creating our own test stands to test this. It was a little bit modified, however we still did test all the direct things that we wanted to from the stand. And you can see here, the stand is actually over in the booth, not too far away, but we created this all ourselves from scratch, the table all the way up, have sensors on this, sensor input, read all the data from it, and actually get good results from this so that we can represent this back to Magna and say, this is the results. And throughout the whole thing, Magna was instrumental in providing the direction to go on which parts to use and everything, how to do everything to their standards to make sure that this testing is not violated. And here's just a few of the parts we had to make. We had to make a lot of custom parts, which involved designing and tooling, machining. Involved some electrical wiring of the motor to get a variable drive and everything of that sort. And as you can see a few of our instrumentation that we used. So this is a huge learning step for us as well to actually create this, to get hands-on with the testing and to be right there. So the results from our testing are unfortunately covered under the non-disclosure agreement, so I can't share them freely. However, I can say that there was a reduction in flow rate and in torque, which was the initial intent of it. And this obviously helps the emissions profile, and of course, emissions are everything right now when we're looking at the industry. So the pump that we did test didn't allow for a large amount of modification to it, but in the future, we could have a design-specific pump that would allow a lot more modifications to it. Magna intends to do further research into this and to see what is possible to do and if this is feasible. Looking forward, there's new emission standards coming out, and there's a high demand for these pumps. These are being currently marketed to OEMs across the world, actually, and Magna Powertrain has a high stake in this, and they would like to continue with their implementation of this in the future. So just a few acknowledgements: Magna Powertrain, UOIT, and the Ontario Centers of Excellence, and our capstone supervisor, Dr. Hassan Kashawi. Any questions?
Did you look at all the competitive stuff that you get your hands on here? Because I think Porsche are really into this stuff right now, and maybe a little ahead of Magna, who really service BMWs, quite frankly. So, anyway.
Yes, actually, when looking at this, I have a lot of knowledge in this from the background working with Magna, and it's actually, Porsche doesn't do a lot of the engine accessory design themselves. They will bring Tier 1 suppliers to do this for them, and this is actually marketed to the OEMs. So there's only not too many companies, Magna Powertrain, Delphi, Geigy, and a few other ones that make these pumps and are currently doing innovations in this field. And I know a lot of the designers at Magna who are working on this. They have one central design center, so they're all looking at these different, benchmarking them to compare. The one that we would do would be, the one that we presented to them would be not as much flow reduction, but for a fraction of the cost of everyone else. And that's the key deciding factor there, is that this can be implemented for a cheap car rather than just the high-end ones, which it's being currently used on.
How did you know to focus on the flow rate? Was that something that Magna said, okay, this is what we want you to focus on, or is that something that you guys came up with on your own?
The main concept of reducing the flow is, I guess, an industry-wide goal, because as the engine starts up and it's cold, just by the nature of traditional cooling systems, coolant is being pumped through the engine, and it doesn't need to be because it's cold. There doesn't need to be cooling. So It's an industry goal to have variable flow so that you can reduce that flow during startup.
I wonder if you could just speak to your project management and team management structure. It sounded like you had some good challenges that you had to overcome. You must have.
Sure thing, absolutely. And there was definitely a lot of challenges and a lot of things that we had to keep in schedule. We had to modify the schedule extensively, and we did have to take out a whole section of testing that we planned to do, with Magna's permission, of course. However, when we were doing this, there was always timelines and using PERT charts and trying to find the crash routes to find the most critical things that we needed, from whether ordering very specific instrumentation or creating parts. It was very, very difficult in that. However, when it come down to it, there wasn't a lot of separation in our work. We would spend 7 days a week, sometimes 10 hours a day working together on this project, all integrated together. So it was real team effort. Thank you very much.
Okay, we're going to backtrack a little bit here. University of Ottawa is here. Please say you're here. Okay. All right. Okay, we're going to have University of Ottawa, who's going to present their project, Enhanced Induction Generator for Wind Energy Converters. And the industry partner was Trias Innovations, and the presenter today is Kingjun Tang. Come on up.
Okay, good evening, everybody. My name is Qianjun Tang. I'm an electrical engineering student from University of Ottawa with our industrial partner Trias Innovation. 2 years ago, we did a presentation on counter-rotating wind turbine, and this is a continuity of that project. And today I'm going to present the control system and the generator itself. Okay, I'm a part of the Green Engineer Group, and our group is a student industrial professional group with a particular interest in green energies that will benefit our community. So from the picture, you can see there are two great projects that we did last year in the Science and Tech Museum in Ottawa. Okay, so now let's talk about wind energy. Wind energy is green. It's easy to convert. There's a lot of interest that concentrated on small wind farms from small family farms or small businesses that looking into the energy market. There's also a lot of products out there, but also associated with a lot of problems. For example, they have this noise issue with small wind turbines. They also have this lack of efficiency and the power quality issue. So our goal is to build a wind turbine which will produce 40% more in terms of power. Will have much quieter in terms of the electrical noise and also the physical noise. And also, because of the increase of the efficiency, we will be able to break even as fast as possible. So what makes a small wind energy converter generator so special? Because it has a lot of limitations. Because wind power is not very consistent. It varies during the time. And also, you are limited in the nacelle, which is 80 feet up in the air. So for maintenance and for the sites, it's another challenge. And most important, when you have different places, locations, they have different regulations for the grade. For example, you have single-phase grade, you have a three-phase grade, somewhere you don't even have a grade. So our solution will be the Trias Innovation generator with luxury winding inside to fine-tune the power factor characteristics. And also, we will have an innovational power electronic system to take care of the conversion from single-phase to three-phase. Our generator will be able to work standalone. And also, we're going to minimize the harmonics level of the generator to provide more clean energy. And also, the efficiency of the generator will be increased. Okay. So to summarize, with the counter-rotating nature, the magnetic clutch, the trias lubrication on the gearbox, the generator, and our control system, we are going to produce a green, clean, efficient, quiet, and smart generator. So with all those goals in mind, we have a lot of resources. Fortunately, by working with Trias Innovation, we built a lot of experience hands-on to realize our dreams, not only on the computer design, but also in our real life. We also have this student workshop in Mansfield provided by University of Ottawa. And our team is a multidisciplinary with electrical student, mechanical student, computer science student, also software guys. By having the relationship with Trias Innovation, we also extended our partnership with other industrial collaborators such as Powerbase, Siemens, GBS, or Canadian Solar. So I happened to heard a joke from my friends. They said, in theory, you know everything, but nothing works. In practical, everything's working, but you don't know why. Unfortunately, in their lab, they have both. Nothing's work, and they don't know why. Okay, but with the collaboration of the industrial, we have the feedback from the industrial, and we have the consolation from the industrial. So that gives us right path. So I would say in our lab, everything's working, and we do know why. Okay, I guess I will stop right there. And just for your information, it also creates a good job opportunity. After I graduate from the university, I will be a part of the Trias Innovation Group. So it is really good for the community, and the bonding from the university and to the industrial really makes a difference. Okay, so if there's any questions?
So I noticed the turbine out on the floor. So can you speak to exactly what your team was focused on?
Our team is concentrated on the generator and the interface from the turbine to the grid.
And could you tell us a little bit about what?
Yeah. Okay. It's a little bit too much information, so I dropped it off from the presentation. So actually, what happens is you will have different regulations at different places. You will have a single-phase grid or a three-phase grid. And you will have a 60 hertz or 50 hertz or different voltage in different countries. So by having those power electronics interface, we will be able to control the regulations from the turbine and to adapt it into the localized regulations.
So just to clarify, when you described the goals, like 40% more efficient and all that stuff, those were not your project goals. Those were the goals overall, and your project goals were what you just described now?
The goal of my project is also to increase the efficiency of the whole system. The 40%, it's the minimum gain of the whole system. By having those power electronics, we will be able to widen the range of our operation window. So we are looking at another 20% more.
So do you know, somewhere in your presentation, you set out a series of objectives and goals you wanted to achieve. Did you achieve all of those, or were those beyond the scope of your actual project?
Actually, at this point, we have, I would say, 70% of the whole testing is done. So the system is up and running. We just need to fine-tune some of the electronics in order to make it better. If there's any more questions. Just for your information, our turbines are right there, around 600. So if you guys have time, just go and visit us. Okay.
Thank you, University of Ottawa. Now, is the University of Western Ontario here? That team, okay. They'll be next. And they're going to present on design of flaps for D-Jet. And the presenter is Adam Shea, from the University of Western Ontario with an industry partner of Diamond Aircraft Industries, Inc.
I should adjust this a bit. All right. Good evening. My name's Adam Shea, with my colleagues Kenneth McKenzie and Owen Marble. Unfortunately, our fourth member, Scott Frame, was unable to be here this evening, but we did our project with Diamond Aircraft Industries Canada. They're located in Southwestern Ontario and London, Ontario, and their main goal of what they're trying to achieve in the near future is to generate a fully composite single-engine jet turbine aircraft. And they will be the first company to do so in the very light aircraft industries. So as we got an industry sponsor, we were assigned a team of 3 engineers. Joost List, the Vice President of Engineering, he was our professional contact, as well as a design contact of Arthur Jalakewicz and a structural or stress engineer under Finbar Collins. So just to give you a brief overview of what a flap does, as our project revolves around designing a flap mechanism. A flap hits certain extensions and rotations in certain positions that you can see here, that as it hits these positions, it alters the aerodynamic profile of a wing, and it allows more lift and more drag to allow a safer takeoff distance at a lower speed. So that's the general overview of that. Oh, that's where I went back. So Diamond Aircraft came to us with a problem. They wanted a flap mechanism that was lightweight, as it's a very light aircraft, always a benefit in the aerospace industry. Something that was structurally sound. They had a kinematic path defined for us, and one big problem that they had was the ease of use with pilots and accessibility of maintenance. And as it follows a complex path and has complex motion, it's harder to access and harder to repair. So what they wanted was a simplistic motion and the investigation of that simplistic motion. As well, we were not allowed to have jamming or be fixed in a locked position, because it's not like a car. You can't pull over to the side of the road and fix your flap. It's pretty critical that it has to stay in the same position. So they came to us. We had to define them. We had to give them a proposal, and we had successful design reviews so that they kept us on the right track and made sure that we were satisfying the customer requirements laid out by Diamond, as well as producing a viable result that could be implemented later. They encouraged, regular contact and weekly updates that we had to send, as well as formal reviews. So we went through, we had a lot of design selection and generation techniques that, under the expertise of our 3 supervisors, we found that we would achieve our goals. We had a constant workload that we could keep aiming towards. And I guess the big thing that we learned from our industry is to split up into teams. So we have 4 people. We used a team of 2 for design and a team of 2 for stress. What this did for us was to allow multiple teams working towards one goal, and there was no backup, and it was 8 months of consistent work. So here's our design solution. We coined this, we call this the rotating slider. In general terms, you would see a complex curved path, or something that you would never see, something you could never analyze. So what we did, we combined two simple movements, translations and rotations. And we combined the 2 to hit our 3 defined paths and to allow us to hit these motions, which you can see here. This video will start playing. This defines what we have done over the 8 months. As you can see, we have a linear actuator that will push our assembly forward. As it pushes forward, we have a set of rollers that will rotate up, as well with the linear translation. We see that we achieve all of our 3 motions. This here actually, I guess I'll get into in a couple seconds. So that is our final design solution. As you can see, if we're trying to aim to solve this problem, we have 3 stations that we have to solve. It's complex motion. That was the hardest thing that we had to find to do. And the way that we found our solution is by finding a common point in all 3 parts of our assembly to get to get our solution and to get the simplest solution that that Diamond will implement. So as we move forward, I guess all of us are graduating students, but as we move forward, this design here, it needs a little bit of optimization design and fine-tuning, but after this fine-tuning, this will actually be implemented into the next prototype of the D-Jet aircraft. It's something that they want to see forward, and it's an innovative design that they thoroughly enjoyed. We satisfied all the customer requirements, and it's it'll be on the next prototype. As we move on, we all have standing interviews with Diamond. The D-Jet program is beginning to ramp up, and as it does ramp up, we all have standing interviews if we do not have jobs already. Thank you. Are there any questions?
Is your new solution affordable?
Pardon?
Is your new solution affordable?
Affordable? The D-Jet is a small market, so as of right now, they have just over 200 orders. So when we think about affordable, I would think about the cost of materials and how we used to design it. It was part of our design analysis to go forward with, using as little material as possible and ensuring that we use proper manufacturing techniques so that we did not go to Diamond Aircraft and say, by the way, your solution costs a couple $100,000 because we didn't know how it was manufactured. It was a simple, we generated pieces that were water jet cut, a nice CNC machine that can cut all of our parts, and that was one thing that it was kept into our brains, that we had to make sure that it could be produced, and yes, it can.
If you all have open offers for this company, do you think you're going to join up with them based on your concept here?
If we do want to, I know personally I do want to continue in the aerospace industry. When the program does ramp back up, yeah, for sure I would love to stay with Diamond. It's a smaller company that provides you a lot of responsibility, but I mean, everything that they produce is innovative. It starts from the ground up. It's not a reiteration. It's to dig in and find a brand new solution to something.
Okay, so that brings us to our final presentation. And I like to think of this one as as your appetizer for the reception that's going to follow this event. It is by the University of Windsor, and it is called Hybrid Automation Systems for Packing Tomatoes and Improving the Efficiency of Box-Making Operations and Space. So that's got to pique your interest. It is presented by David Impens, and the industry partner was Clifford's Produce.
All right, good afternoon, everyone. We are a group from University of Windsor. Members include Melina Portillo, Thomas Flood, and myself, David Impens. We are here to present our project, The Benefits of Redesign in a Produce Packaging Plant. It will include an industry sponsor overview, problem statement, project planning and timeline, problem solution, and conclusions. The greenhouse produce industry is huge business in southwestern Ontario. The industry in Essex County exceeds $500 million. Within the market segment is Clifford Produce. They were established in 1976 as a co-op of farms and located in Ruthven, Ontario. They package and ship many varieties of produce across North America. Within the company, our primary contact was Angelo Filoni from the finance department. Although the location was 45 minutes away from our school, we normally visit the facility twice a month. In between face-to-face meetings, we kept in contact, asked questions, exchanged materials through phone meetings and emails. Everyone was very receptive of our presence. All employees cooperated with our group and our project direction. We can't say enough about the professional atmosphere that they treated us with. When the project started, Clifford Produce was impressed with all the areas that industrial engineers learned in school and wanted to use some of the skills to improve and analyze 2 different areas. The first area is the box making area, where they produce all the boxes that the produce goes in. They have 3 box making machines in this area, and they could all benefit from a more efficient changeover between the different products. Also, production levels were so high, so much higher than demand, that they actually resulted in excess inventory. The second area is the cocktail tomato packaging line. They currently pack manually with a limitation on capacity. One of the major products of the line is the Fusion Pack, which combines 4 different kinds of cocktail tomatoes in one package. To accomplish that, right now they use 5 workers. To manage our project and keep on track of the progress, reach our milestones, 4 phases were used. The scope phase, where we listened to the voice of the customer, made the engineering specifications and asked questions. The analysis phase included literature review, observations, and time studies. Our decision phase introduced tools to determine root causes, assess feasibility, along with our available budgeting. And finally, our implemental phase. This was the last couple of months when all our solutions were implemented and brought online with production. Tools used include time and motion studies, investigation of demand versus production, simulation software, Pew charts, feasibility studies, computer-aided design for the drawings, and a design of experiments for the new automation concept. Some of the solutions in the box making area include an economic production quantity model to schedule production on machines and incorporate the manpower. A glue nozzle bracket was actually fabricated to reduce overall changeover a full 14 minutes. A changeover table was fabricated and results in reducing manpower from 3 to 2 workers, and also improving the safety of those workers. Brainstorm Solutions from the cocktail tomato line. We now introduce trolleys holding the produce instead of pallets, and along with that, a buffer table was introduced at the end of the line to improve quality by reducing the risk of the product falling and piling up. We also looked at the unique issues with automation. These include the many different types and shapes of the possible tomatoes, and their standard package, which is called 1 pound. When full is actually over 1 pound. Therefore, volume is constant, but automation equipment fills these clamshells by weight. When filled to 1 pound, as you can see on the outside packages, they don't seem filled. Experiments were conducted to prove the difference between the type of cocktail tomatoes and the volume to weight ratios. And then eventually, a simple prototype of the concept was produced. So as a result of these solutions, an estimated cost savings for Clifford Produce after full utilization of the project ideas was $107,000. So to conclude, our project opened communication between departments and encouraged them to work together. We addressed the need of continuous improvement so that they can keep their market share and the industry as a whole within Ontario. Because of this project and its benefits, the sponsor wishes to continue working a relationship with the school. We as a group gained valuable practical experience within a company that was accepting, encouraging, and always attentive to our ideas. We also learned that unlike the educational environment, solutions are not produced with a stroke of a pen, but real practical solutions should be thought out because they affect many areas and real employees, and mistakes cannot be taken away with an eraser. So this project would not be a success without the support of Clifford Produce, OCE, the University of Windsor, our instructor, Dr. Jill Urbanik, our advisors, Dr. Hodel Maragi, Azab, and last but not least, our industry contact, Angelo Filoni. Thanks.
Could you go back and you went past this slide on how much was the need?
Yes.
That's a big dollar.
Yes.
For one single project. And you've just looked at the box area?
The box making area and the tomato packing line.
So that's it. That's all you've looked at so far.
That's it.
That's pretty good.
So the breakdowns were, we actually took the time studies after we already implemented it, and then saw how many times that changeover would have happened, and then times it by their employee's wage. So each one, that's why some of them are higher, some of them are lower, and there's a lot of other things that we actually introduced, but yeah.
Sure. But I'm curious, Mike, as you were talking about the bracket, my first thought was how much did that save? And it looks like to me...
So it actually saved 14 minutes per changeover.
And that amount, the dollar amount translates to $817. Is that what the bracket is here on your slide?
Yes, because we actually said it's 14 minutes for one changeover a day. So that's why some of the stuff is very conservative. We're saying they only change that particular only one time. Yeah.
So in the real world, it might be.
Yeah.
Interesting. Thank you.
All right, thank you.
Well, that concludes our presentations for this evening for this competition. I'd like to take a minute just to thank all of the student presenters who did an amazing job of representing the talent that's coming out of Ontario academic institutions these days. Also, the industry partners who invested their time and money into these projects, and hopefully they'll take advantage of the talent they've helped to develop. So I wanted to invite everyone also to take a look at the projects. There are bigger displays of the equipment that the students brought up here as prototypes. You can see them in the advanced manufacturing section and in section 900 as well as aisle 600. So hopefully you'll take a walk by them tomorrow. I'd also like to take a minute to thank our judges. Thank you very much for your time. Thanks so much. And for your questions. And before we adjourn, I'd like to mention that we do have this year a Career Connects corner that we're featuring for students and industry. It is just located 2 booths down. It's quite a big area, and in that area, students can get resume advice, they can practice interviewing, they can talk to Lucy Keating and get really good advice on how what not to do in an interview, or what questions to ask, and how to answer difficult questions. Also, you can register your CV online. We have a new online job matching site that we are hoping that you'll all sign up for sometime over the course of the next 2 days. So tomorrow we will be presenting the awards at the luncheon. The luncheon starts at 11:45, goes to about 1:30, and that's when the student awards will be announced. There'll be 3 awards presented for this competition. One for each section, so there'll be an college award, an OPA award, as well as a university award. So hopefully you'll take part in that. And now we're on to the reception. So enjoy the rest of today, have a drink, and enjoy the show floor. And hopefully you'll be back tomorrow. Thank you very much for coming.